I'm Lou Glab. Been at NASA Langley for almost 31 years and assistant branch head of the Aeronautics Systems Engineering branch.
And I'm Robert McSwain. I've been at NASA Langley for about 2.5 years, and I work in the Aeronautics Systems Engineering branch with Lou. Greased Lightning Almost Ready to Fly, which is the vehicle we're out here flying today, is the trainer aircraft for the Greased Lightning.
Although the GL-10 is just another drone, it's much cooler than a remote control helicopter or airplane. You see, that's kind of because it's both. It can take off like a helicopter, and then mid-air tilt its wings and fly like an airplane, which greatly increases fuel efficiency.
What these vehicles can do is they can take off and land like this multi-rotor here, but then they can go into forward flight mode, which is much more efficient and really a big range extender. So that's the attraction for tilt wing technology. The GL-10 was designed to provide a prolonged, long endurance surveillance requirement for military application initially.
Right, and just to add to that, the efficiencies you're going to get with a fixed wing are going to be better than a multi-rotor that is having to produce all of its lift with motor props versus a wing that's been designed for that cruise condition. So, any opportunity you have to use a fixed wing configuration for performance and use a vertical takeoff capability so your takeoff and landing requirements are very, very low. You don't need a 5,000 foot long runway in order to operate there. You can operate anywhere, and you still get that range as if you had a 5,000 foot runway.
Although the GL-10 is still in the testing phase, it shouldn't be long until we see a full-size aircraft of this sort.
Look at the X-57, which is Maxwell is named. It is a real full-size aircraft with distributed electric propulsion technology on it. So,
right. The difference with the Maxwell is it's going to take off and land in forward flight.
Right. It's not a VTOL, but
right.
It does have distributed electric propulsion.
Exactly. So the GL-10, right? That's supposed to be an unmanned, large unmanned vehicle, 24-hour endurance. It's got a generator on board to recharge the batteries, to do takeoff and landings with. So that could possibly be available in several years, 5 years, depending on how hard they want to work at getting something like that going. Other aircraft like this, you could see something like this for on-demand mobility. So the big, the holy grail of flying cars could be enabled by something like this.
Now you have to ask yourself, how much does something like this cost?
If we lost that airframe or that flew away, that's probably maybe $600 worth of equipment overall. Nothing very expensive in it. What is expensive is the time and labor we put into it. So, we probably have what, $10,000–$20,000 invested in the rebuild of that aircraft. The GL-10. That aircraft is probably valued more at like $1 million, given all the time it took to design, fabricate, and install and get it together.
With all of these new possibilities over the horizon being exposed by the GL-10, it all boils down to one question. Whose idea was it to name this thing the GLARF?
That would be our favorite Bill
Bill
Fredericks, I believe. A very creative engineer back at NASA Langley. I think he created the Greased Lightning and also the GLARF.
And the backstory there is that it's greased because the vision was to have a motor on board that used gas and oil. And then we also were looking at this electric propulsion system. So that's the Lightning. So he put Greased, Lightning, hybrid. That's how he came up with GL-10. And then the GLARFs were obviously just an afterthought. Greased Lightning, Almost Ready to Fly. Nice acronym. I, as well as Bill, like acronyms. So
yes. Yes.
Hold on.